Hello, I'm Seema and welcome to part 6 of the chapter Redox Reactions. We were doing the different types of redox reactions, and in part 5, I told you that the different categories of redox reactions there are 4 categories, and I discussed the first 2 categories, that is the combination reactions and the decomposition reactions with you. In this video, we are going to do the third category, that is the displacement reactions. And in the next video, we'll do the fourth category, which would be the disproportionation reactions. So let us come straight to the point. What is a displacement reaction? You've already studied about the kinds of chemical reactions in class 10, where you did the different categories of chemical reactions, and we said you have studied the displacement reactions. When one metal takes the place of a metal atom in its salt solution, the reaction is known as a displacement reaction. Or it could be a non-metal taking the place of another non-metal in the salt solution. So displacement is basically the similar type of atoms, whether metals or non-metals, who take the place of another in a compound. So such a reaction is known as a displacement reaction. You could take an example of 2 people sitting together and them not being the best friends, and it was early morning and you students are allowed to sit wherever you want, and your best friend did not come. So you just found whoever was there and you sat with another person and you were sitting there, and all of a sudden your best friend arrives. And when that best friend arrives, he comes and he taps the shoulder of this other friend who's sitting next to you and says that, would you please move to the other side because I want to sit with my best friend. So now you are sitting with your best friend and you're kind of happier. So a displacement reaction is somewhat like this. There is the friendship between this part of the compound and the best friend is more than the friendship with the other atom or the group which is already present with it. So when that takes the place of this other friend, it is known as a displacement. So he displaced the other person. So such a reaction is known as a displacement reaction. I will not go more into details of this because you already know what a displacement reaction is. Now displacement reactions are, in terms of redox reactions, since we are studying, you categorize them into 2 types, metal displacement and non-metal displacement. Basically, it depends on the reactivity series of metals. And if you know the reactivity series of metals or the activity series of metals, you know that in the activity series of metals, there is one non-metal, which is hydrogen. It is because of this hydrogen that we talk of this other category also. But displacement is a reaction is basically a metal displacing a metal or a metal displacing a non-metal from its compound. Now, before I actually start explaining the reactions to you, I guess writing down the reactivity series might be a good idea. Let me just write down the series for you because that makes it very easy to memorize it. Now I'll just take the metals, earth metals, you understand. I'll put the metal here to remember that I have to write this. The reactivity series I had memorized as a student, and now when you look at different websites, you find the reactivity series is given a little differently in different websites. But the one that I memorized is the one that is still being followed in the NCERT. So I will write that down for you. But when you are working in the laboratory or later at a later stage, when you let us say you decide to pursue chemistry, you might want to refer to the activity series that is given. There shouldn't be much of a difference, barring 1 or 2 metals which have been placed differently. But otherwise, the activity series, you just memorize it, you're good for once in your life. The activity series is potassium, barium, sodium, calcium, sodium, magnesium, aluminum, zinc, chromium, iron, cadmium, cobalt, nickel, tin, lead, hydrogen, copper, mercury, silver, gold, and platinum. Out of the entire reactivity series, it is hydrogen which is a non-metal, and all others are metals. And this is the sequence of their reactivity. Out of all the metals, the most reactive is potassium, and it has the strongest tendency to get oxidized. Metals are those elements which have got 1, 2, or 3 electrons in their outermost shell, and they become stable by losing those. So they have a tendency to lose electrons, and loss of electrons is oxidation. So potassium is the metal which would be, actually even above potassium you have lithium. But in the NCERT, this is the sequence that is given to you. So potassium, let us say, has the highest tendency to lose electrons. And therefore, if it is really good at getting oxidized, it is a very good reducing agent. It is the best reducing agent. Now, before we come to this, let me just help you memorize the reactivity series or the activity series, because if you memorize it, it's very easy to memorize it one. And if you memorize it, doing these equations becomes very easy for you. So let us memorize. How I did it, I'll just tell you how I did it. I made a kind of a sentence out of this, and it was a sentence of a language that is not spoken or it is a sentence of a language that I don't know. Yet I made that sentence and I used to speak it as if I understand the sentence very well, and that helped me kind of memorize it. And for 17 years I've helped my students memorize the activity series with the same sentence. Therefore, I'm sure you would be able to memorize it in the same way too. The sentence that I made, it was, I took these 4 and I gave a break here. We said Kaaba Kana. Now you may say, take it in Hindi, Kana is someone who has a smaller eye or one eye that is defective. Kaaba could be a place. Imagine however you find meanings in it. But this is how I would say it. Kaaba Kana Mag al Zankar. Kya kar? So Mag al Zankar. So, Kaaba Kana Mag al Zankar. Fikad ko Nisan pub. Fikad ko Nisan pub. Haku hug ug. Haku hug ug. Oh, but. So I know it's funny and I know it really makes no sense, but just enjoying yourself with a little foolishness, if it helps you to memorize, there's no harm. So I will repeat this, and if you want, you could repeat after me. Pause the video here wherever you need to and repeat. So I'll give pauses now when I'm saying it. Kaaba Kana Mag al Zankar. Fikad ko Nisan pub. Haku hug ug. Oh, but. Kaaba Kana Mag al Zankar. Fikad ko Nisan pub. Haku hug ug. Oh, but. Kaaba Kana Mag al Zankar. Fikad ko Nisan pub. Haku hug ug. Oh, but. I'll give the gap again now. Kaaba Kana Mag al Zankar. Fikad ko Nisan pub. Haku hug ug. Oh, but. So I guess if you just repeat this over the day, within a day, or rather within 1 hour, you will memorize the reactivity series. And this is going to be helpful to you not only in redox reactions, it is going to help you a lot when you do electrochemistry next year. Therefore, I would suggest that you memorize this. Now, from this we see that potassium, why is the reactivity series important and why must we learn it and what does it tell us? When you are talking of displacement reactions, any metal which is stronger has the ability to displace a weaker metal. So when I say this has the strongest tendency to get oxidized, so we'll say this is the strongest metal, and therefore this is the weakest metal chemically in terms of reaction, in terms of its reactivity. That is why it is called the reactivity series. So any metal which is higher up in the activity series will have a tendency to displace a metal that is lower down in the reactivity series, since it is more reactive. So displacement reaction will only take place if you have a free metal and you have the combined metal, but the combined metal should be, or the combined metal means metal in the presence of combined in the form of a compound as a salt. So the displacement will only take place if the free element or the free metal is higher in the reactivity series, and therefore it is stronger, it is a better friend of that negative ion, and therefore it would have the ability to displace that other metal and take its place, right? So this is just one part which I felt is really important to memorize, although right now to understand redox reactions it may not be very important, but in terms of chemistry and your study of chemistry, it is really important to memorize the activity series. Now let us come to the displacement reactions. We first talk of metal displacement. Now look here, now you have a salt of copper sulfate, and the metal that you have is zinc. Look at the reactivity series. Copper is here and zinc is high up here. Do you think zinc can displace copper? Of course it can, right? Because zinc is higher up, and any metal which is higher up will have the capability to displace the weaker metal. So that is what happens. What happens? The copper is removed and it is sent away, the lesser friend is sent away, and zinc on the other hand forms zinc sulfate. In terms of redox reaction, what happens? In copper sulfate, copper had a charge of +2, sulfur +4 and oxygen -2. The sulfur and oxygen remain the same in the product also. And zinc had a charge of 0 when it was in the elemental form. So when zinc takes the place of copper, zinc loses 2 electrons, and these 2 electrons are gained by copper. So copper, when it gains 2 electrons, it turns from +2 to 0. So what is gaining of electrons is reduction. So copper gets reduced while zinc loses 2 electrons, therefore zinc gets oxidized. Therefore, this is a redox reaction and it is a displacement reaction. So in which zinc displaced copper by zinc itself got oxidized and it reduced the copper. Similarly, this other example is where you have vanadium pentoxide, V2O5 plus calcium. Although vanadium here, if you see in this reactivity series, it is not there, but vanadium is less reactive than calcium. Another thing that you can memorize it is that alkali metals and alkaline earth metals have only 1 or 2 electrons in their outermost shell. And then you have a series of elements who are the transition elements also. So out of all the metals, the alkali metals and the alkaline earth metals generally are stronger. So when you have calcium, calcium falls in the second group. So barium, strontium, calcium are in the second group. Very reactive alkaline earth metals. So when you have calcium, it can displace vanadium. And from V2O5, in V2O5, the charge on vanadium is +5 and it turns into 0. And calcium goes from 0 to +2. Therefore, calcium from 0 it goes to +2, and vanadium from +5 comes down to 0. So vanadium is getting reduced and calcium is getting oxidized. So the next one is titanium chloride and magnesium. Magnesium is more reactive than titanium. Again an example, this is the biggest problem with NCERT. They always choose things, they make you memorize one thing and then they'll choose things which are not included there. Yet, all metals are not covered in this series. When you do the electrochemical series, you'll get to know the electrode potentials of each one, and that would help. So this is only giving you covering partially some of the metals, some are still left behind. Anyway, titanium chloride and magnesium, when they react, magnesium is more reactive than titanium. So titanium has a charge of +4, chlorine -1, magnesium 0. But when titanium is separated out, titanium becomes 0, so it goes from +4 to 0. It means it has got reduced since the oxidation number is decreasing. And magnesium goes from 0 to +2, its oxidation number is increasing, so it is getting oxidized. Similarly, you have chromium and aluminum. Thank God you have both of these here. So chromium and aluminum. Aluminum is more reactive than chromium. So obviously aluminum can take the place of chromium and therefore the displacement occurs. And in order to understand it in terms of redox reactions, look at their charges. Chromium was +3, it becomes 0. So it is getting reduced. Aluminum was 0, it becomes +3, therefore it is getting oxidized. Now, I told you, when we talk of non-metal displacement, we are still depending on the same activity series mainly. And why? Because we are concerned with this hydrogen. Sometimes these metals, they can displace, alkali metals and alkaline earth metals basically, mainly, would displace hydrogen. And they would displace hydrogen from cold water. Now metals can, most of the metals can displace hydrogen from water or from its compounds like acids. But what would be the vigor of the reaction, how violent or how slowly the reaction would take place, would depend on the difference in their reactivity. The greater the difference in the reactivity, hydrogen is so low, potassium is so high, the difference between their reactivity is so much that potassium is not going to come politely and tell hydrogen, excuse me, can you move, can I go meet my best friend? Potassium is really, really strong. Potassium, the moment it enters the door of the classroom, hydrogen is going to run away as it is. Because he would be so scared of potassium. Potassium is really, really strong. So the stronger, the wider the gap, the more violent or the easier would be the reaction. So when we talk of non-metal displacement, we say alkali metals and alkaline earth metals who are quite reactive. Now the alkali metals, that is lithium, sodium, potassium, rubidium, cesium, francium, and the alkaline earth metals, that would be barium, magnesium, calcium, strontium, beryllium and radium. Now these would be far more reactive because they have only 1 or 2 electrons in their outermost shell and it's very easy to lose these electrons. So they have a tendency to very easily displace hydrogen from water. So we'll say all alkali metals and alkaline earth metals can displace hydrogen easily, which means that they can react with cold water and they would react violently with cold water to remove the hydrogen. For example, sodium combines with water to give you sodium hydroxide and hydrogen is given out. Sodium has displaced hydrogen. So sodium had a charge of 0 and in water hydrogen had a charge of +1. So sodium becomes +1 and hydrogen becomes 0. So sodium got oxidized and hydrogen got reduced. Similarly, if you had calcium, calcium can also displace hydrogen from water, from cold water, because it is an barium, strontium, calcium, these are alkaline earth metals. So since it is an alkaline earth metal, it is far more reactive. And if you really look, even in the reactivity series, calcium is quite high up, higher than hydrogen. So this displaces hydrogen from water, from cold water. And the reaction here, calcium from 0 goes to +2, it gets oxidized. Hydrogen from +1 goes down to 0, therefore it is reduced. If you have less active metals like magnesium, iron, they would not react with cold water. They would displace the hydrogen from water. But the conditions of the reaction would have to be a little more severe. So you'd have to heat up the water and now they would react. So magnesium combines with water to give you magnesium hydroxide and hydrogen. Magnesium was 0. Since we are talking in terms of, we are studying this as redox reactions, it is important to remember what is getting oxidized and what is getting reduced. So magnesium is getting oxidized, hydrogen is getting reduced. Similarly, in the case of iron and water, iron would react with warm water to give you, iron would get oxidized to give you +3 charge from 0 and hydrogen from +1 would go down to 0. Now this was about reaction with water. If you have still lesser reactive metals, you might need steam to displace the hydrogen from water. Now, metals can displace hydrogen not only from water, where hydrogen may be present as H positive, but also from acids, where in acids also hydrogen is present as H positive. So a metal can displace it and get oxidized and take the place of that H positive. For example, you have cadmium, tin. They would displace any metal would which is higher than hydrogen in the reactivity series, would displace hydrogen from its acid. For example, zinc combines with HCl to give you ZnCl2 plus hydrogen. Magnesium combines with HCl to give you MgCl2 and hydrogen. In each of these, the same thing is happening. The metal is 0, hydrogen is +1. The metal acquires the charge, a positive charge, and hydrogen becomes neutral. Therefore, hydrogen gets reduced and the metal gets oxidized. Even here, magnesium was initially 0, hydrogen was +1, chlorine was -1, chlorine remains -1, magnesium becomes +2. Sorry, I wrote 2 plus. It should be, the plus should be before it. +2, and this is 0. The reason is that when you write 2 plus, it becomes a mathematical quantity. It is as if you're waiting for something to be added onto it. So +2, when we say, here the plus signifies the charge, positive charge. Similarly for iron also, with FeCl2, it would be Fe2. Fe would be 2 positive, it was 0, it got oxidized, H was +1, it got down to 0, it got reduced. Now, this type of displacement reaction is used to prepare hydrogen in the laboratory. Now, all you have to do is you have HCl and you have metal, and if you add like zinc scrapings, you can use, or magnesium or iron filings can be used, and if you pass concentrated HCl through it, it'll start giving the hydrogen gas. So this is a method that is used to prepare hydrogen gas in the laboratory. Now, just as we have the activity series of metals, we are talking of non-metal displacement. In the case of halogens, halogens are also very reactive. The only difference is that halogens, instead of getting oxidized, they get reduced. They have a tendency to get reduced. So just as we have a reactivity series of metals which tell us which is the stronger reducing agent, in the case of halogens, you have the opposite, that is, which is the stronger oxidizing agent. So we know fluorine is the smallest, it has the strongest, it is the most electronegative, it has the strongest tendency to pull the electrons towards itself, and therefore fluorine has the strongest tendency to get what is gaining electrons, to get reduced. Therefore, it is a very good, it is the best oxidizing agent. On the basis of that, the halogens can also be turned into an activity series, in which fluorine is on top, fluorine, chlorine, bromine, iodine, astatine. Mainly, we see reactions. Astatine is rare and we don't see its reactions as much, but fluorine, chlorine, bromine, iodine, we normally use. So we find that iodine is the least reactive since it is a large atom. Attracting electrons is not so easy, so its electronegativity is the highest among the halogens. So if you talk in terms of displacement, fluorine would be able to displace all three because they are less reactive. Chlorine will be able to displace bromine and iodine. Bromine will be able to displace iodine. So according to this also, according to this activity series of the halogens, fluorine can displace all other halogens, chlorine can displace the ones below it, bromine can displace the ones below it, and iodine can displace astatine, which is not usually, that reaction we don't see. But in the case of fluorine, such a displacement is not possible. Why? Because it is the most reactive, and in order to displace fluorine from its salt, you will have to use electrolysis. So this can be done electrolytically, but it cannot be done by chemical methods. So let us see some of these reactions. Activity series of halogens also exists from fluorine to iodine. The oxidizing property goes on decreasing. Therefore, fluorine can displace other halogens. And not only halogens, oxygen also has a pretty high electronegativity. So in addition to the halogens, fluorine is so electronegative that it can actually even displace the oxygen in water. Its electronegativity is so high that it can not only displace the other halogens, it can displace oxygen too from water. So let us see the examples, such examples. And these two examples that we are taking are again important in the laboratory. Chlorine combines with potassium bromide to give us potassium chloride and bromine, which means chlorine being stronger can displace bromine. So we get KBr when it reacts, chlorine was 0, it turns into -1. So chlorine gets reduced, and bromine was -1, it turns into 0, so bromine gets oxidized. That is okay. Similarly, if you take chlorine can displace iodine also. So chlorine with potassium iodide will give you potassium chloride and iodine will be given out. Here chlorine had a charge of 0, iodide was -1. Now chloride becomes, potassium remains +1 in reactant and product. So the change is taking place in chlorine and iodine. So chlorine goes from 0 to -1, therefore it gets reduced, and iodine goes from -1 to 0, so it gets oxidized. Now, why did I take these two examples and why did I say that they are important in the laboratory is that both the bromine and chlorine which are produced, they are colorful, they are colored, and they dissolve in carbon tetrachloride. So in the laboratory, if you have a salt that contains chlorine or that contains bromine or iodine, the bromine and iodine will give colored solutions. And these colored solutions would dissolve in carbon tetrachloride. So this we use as a hint to identify if the salt had bromine and iodine. So if you have any bromide, any salt that has bromide or iodide, what will you do? You'll pass chlorine gas through a solution of that. And when you pass chlorine gas through that, the chlorine will displace the bromine and the iodine, and the bromine and iodine produced will give color and they will dissolve in carbon tetrachloride. So which will confirm and which would tell us that okay, this compound or this salt was a bromide or it was a chloride. It helps you to find out the anion in the salt. And this test is known as the layer test. Now, from this we can see that bromine can displace iodine. So let us take one example of that. Bromine combines with iodide ion, and it could be potassium iodide again, and you will get KBr and iodine will be given out. Now generally we write this reaction like this, where the metal is actually not undergoing oxidation or reduction. Therefore we tend to ignore that species that is not undergoing any change according to redox, according to its importance to us in the redox reaction. Therefore this becomes a general way of writing it. So generally, what is halogen displacement? Halogen displacement is nothing but the negatively charged ion of a halogen which turns into the neutral halogen. It gives you the halogen gas or the halogen liquid, whatever it is, plus it 2 electrons, which means in the halogen displacement, the negatively charged ion turns into a charge 0, into neutral halogen. So it gets reduced, and it is this reduction which is taking place in halogen displacement. And as I told you, in the case of fluorine, if you want something to displace fluorine, it is not possible unless and until you do it through electrolysis. So if a child does not listen to you directly, then what do? Give him electric shocks. He will have to do what you want to. So fluorine is so strong that it is not possible to displace it. So you have to resort to electrolysis, a strong method. You really have to force that reaction. So you use electricity to carry out that reaction. So these were the displacement reactions, that is metal displacement and non-metal displacement reactions. With that, I'll wind up today's video. If you found it helpful, give it a thumbs up, subscribe to my channel, recommend it to your friends, and please keep returning for more videos in chemistry. Thank you for watching, and bye-bye for now.